Hi! In this video we will talk about the unit circle and how it can apply to sine and cosine. So in this video you will learn what is the unit circle, how to estimate different values of sine and cosine given the angle, and finding the relation between sine x and cosine x, so sine of some angle and cosine of some angle. So let's start with an example. Suppose you were asked to find these values without the use of a calculator. Sine of 30 degrees and sine of 90 degrees. So remember, sine and cosine of an angle is the ratio between the opposite side and the hypotenuse and the ratio between the adjacent side and the hypotenuse in a right-angled triangle. So these are the definitions and this is the picture, the right-angled triangle. So starting with sine of 30 degrees. Now we can simply construct a right-angled triangle where V is 30 degrees. And an example of that would be where the hypotenuse is 2 and the opposite side is 1. So the hypotenuse has length 2 and the opposite side has length 1. So in particular, in a 30, 60, 90 degree triangle, the hypotenuse is always twice as long as the opposite side. And this is something that we will not go into right now. Now, we get that sine of 30 degrees, it was the opposite side divided by the hypotenuse, so that is 1 divided by 2. Now, suppose we were going to look at our second example. Now we would get a drawing something like this. The angle was 90 degrees and we see that this doesn't really work. It's not a triangle, it's just two parallel lines. So for this we need the unit circle. So the unit circle. The unit circle is the circle with center in origin 0, 0 and radius equal to 1. So it looks like this. You have a circle, the radius is 1, and the center is in the origin. So the x-coordinate 0, y-coordinate 0. Now what we have drawn here in addition is that we have drawn a point on the circle. We have taken the radius from the center to that point, and also we have taken the height from that point down to the x-axis and from that point to the y-axis. And this is a way to illustrate the x value and the y value of that point. So taking out the triangle in this unit circle, we get a triangle with angle V. It's a right angle triangle. The hypotenuse is 1. And the opposite side we have denoted A, which is red color, and the adjacent side we have denoted B in blue color. So in this example, we will take the point which has x and y coordinates 0.6 and 0.8. So if you look at the picture, we have marked the point 0.6 and 0.8, and we have taken the radius from the center to that point. So what you can see is that the x value is 0.6, the y value is 0.8. So if we take out that triangle and we look at that triangle, you see that the x value was 0.6. Now in this red, blue, green triangle, we get that the hypotenuse is 1. The opposite side to the angle V corresponds to the y value. So what does that mean? Well, that means that the y value, which was 0.8, will be the length of that red side, the opposite side. So the length of that opposite side equals the y value. And the same applies to the adjacent side. So now the adjacent side is the blue side, and this has length 0.6, and that is because the x value was 0.6. Now, by using the definition of sine and cosine, we get first that sine of v is the opposite side divided by the hypotenuse, and now we have the opposite side was equal to the y value, and the hypotenuse was 1, so we get the y value divided by 1, which equals just the y value, because dividing by 1, it just, you don't, because by dividing by 1, you simply get the denominator. Now, the same we can do with cosine v. So cosine v is the adjacent side divided by the hypotenuse, but we know that the adjacent side corresponds to the x value and the hypotenuse corresponds to 1. So we get x value divided by 1, which is simply the x value. Therefore, when we want to find sine or cosine of some angle, we can simply draw that angle in the unit circle and measure the y value, which is sine v, and the x value, cosine v. If we want to find the value of sine 20 and cosine 20, we can simply draw the unit circle with v equals 20 degrees, and we can look at the y value and x value. So looking at this picture, what we have done is we first drew the unit circle. That is the circle with center in 0, 0 and radius 1. And then we measured up 20 degrees. So you see here v is 20 degrees. And then we wanted to measure what are the y value and the x value here. So we measured that the y value was 0.34 and the x value was 0.94. So that means that sine of 20 degrees, which in the last slide we saw that sine of 20 degrees, in the last slide we saw that sine of some angle equals the y value. So sine of 20 degrees equals the y value here, which is 0.34. And cosine of 20 degrees corresponds to the x value, which was measured to 0.94. The great thing about the unit circle is that we can use any angle we want. The angle can be 0, the angle can be greater than 90 degrees, or the angle can even be negative. Or of course, the angle could be in between 0 and 90. Now going back to our example of finding sine of 90 degrees. Now using a right angle triangle did not work. Now using the unit circle, that works. Now let's look at what is drawn up here. So we take the point on the circle which gives us the angle to be 90 degrees. Now that point is the point where the x and y coordinates are 0 and 1. So what does that mean? That means that since the sine corresponds to the y value, that means that sine of 90 degrees is equal to the y value here, which is 1. And we have the answer. Now using the unit circle, we can find a lot of different values for sine and cosine. Now try and fill out the table below. So here we have different angles. So we have 0, 90 degrees, 180 degrees, and 270 degrees. And I want you to try and fill out what are the sine of those values. And one is already filled in here, sine of 90 degrees, which we already solved. So you need to draw the unit circle and place these different values and place the different angles. Now finally, I will show you a nice relation between sine and cosine. So let's bring back that red, blue, green triangle from the unit circle. Remember that the sides are the hypotenuse, which is r, is equal to 1. The opposite side, which was the y value, was equal to sine v, and the adjacent side, which was equal to the x value, was equal to cosine v. So it looks like this. Now, since this is a right angle triangle, we can use Pythagoras' theorem. It is stated as a squared plus b squared equals c squared. So a, b, and c are lengths in a right angle triangle, and c is the hypotenuse. So plugging that into this concrete example, we see that a and b can be sine v and cosine v, and c, which is the hypotenuse, is equal to 1. So we have sine v squared plus cosine v squared equals 1 squared. And since 1 squared is just 1, we get this nice relation. So you might ask yourself, why is this nice? Well, the reason why this is nice is that if you know sine of some angle, you know, for instance, that is 0.5, then you can square that and you can subtract that on both sides, and now you can find what cosine v is. So let's put that in another way. So if you know sine v, then you have an equation with just one unknown, and this you can solve quite easily. It's just simple algebra. So I hope this made the unit circle clear, and if there is any question, just post them in the comment below or ask them directly to me. So thank you for watching.